Your dashboard takes 8 seconds to load because 47 database queries run one after another. The team assumed server components would batch them automatically. They didn't. In Next.js 15, unstable cache was renamed to cache. From Next.cache, which may conflict with React's cache from React, the article uses the Next.js 14 API. For Next.js 15+, use import cache from Next.cache for persistent caching and rename React's cache import to avoid collision. When fetching related data in a list, e.g., authors for each post, the n+1 problem arises. Use a batching utility like Data Loader to batch multiple queries into one. This is especially relevant for database queries in server components. When a cached entry expires and multiple requests arrive simultaneously, all may trigger a fresh database query, cache stampede. Mitigate by using stale while revalidate via revalidate option or by implementing a mutex/lock around the cache function. Next.js's data cache handles this for fetch, but for unstable cache, you may need external tools like Redis or a dedicated cache library. Let's break down data fetching in Next.js 16, server components, streaming, and suspense, how it works, and the exact mistake behind that failure. Server components are async functions that directly await data. Instead of fetching on the client, you fetch on the server and render HTML. This eliminates client-side loading states and reduces JavaScript bundle size. When you call fetch in a server component, Next.js automatically caches the response, but database queries via Prisma, Drizzle, or PG do not go through the data cache. A page with 3 widgets calling the same Prisma query hits the database 3 times. Here's the contrast. Fetch, with a revalidate option, is automatically cached. The Prisma call below it hits the database every time. This is the confusion that led to the 47 query dashboard. React's cache function deduplicates calls within the same render pass. If 2 components call the same cached function, only one database query executes. The second caller gets the cached promise. Wrap your data access function with cache. Now, if both layout and sidebar call get current user 123, only one database query runs. The second call awaits the same promise. While cache works within one request, unstable cache persists across requests. It's the database equivalent of fetch's data cache. You set a revalidation time and optionally tags for on-demand invalidation. This caches the product list for 60 seconds. The tags array allows you to invalidate this cache from a server action using revalidate tag products. A waterfall happens when independent data fetches are written sequentially. 300 ms queries take 900 ms. With Promise.all, they take only 300 ms, the max of the 3. The first version waits for each query in sequence. The second starts all 3 at once and waits for all to complete. This simple change cuts load time by 2/3. Even with parallel fetching, the page waits for all data. Suspense boundaries let you stream each widget independently. The page shell renders immediately with skeletons, and each widget appears as its data query completes. Each widget is wrapped in suspense. The page shell renders immediately. Revenue widget streams in when its data arrives, no waiting for the slowest widget. If all queries need the same userid from the root params, they should be parallel. Only when query B needs data from query A's result is a waterfall necessary. Always fetch at the highest possible level. The first example has a genuine dependency chain. You can't fetch the product without the order. The second example's queries all depend on the same userid, so they should be parallel. Preloading starts a query as soon as the module loads, before the component renders. When the component awaits the same cached function, it gets the already running promise, often already resolved. Call preload user at the top of your layout to start the query immediately. The later await returns the same promise, no second database call. Root segment configs control caching at the root level. Revalidate sets time-based revalidation. Dynamic equals force dynamic disables all caching, use sparingly. Configs inherit from parent layouts. Use revalidate for most pages. Force dynamic is for real-time data only. it disables all caching and forces a fresh render on every request. This is the same issue we highlighted at the start. Here's exactly why that happened. The team assumed fetch caching applied to Prisma calls. Each widget independently fetched its data sequentially. With 12 widgets, that's 12 sequential queries, but some widgets made multiple queries, totaling 47. Under 100 concurrent users, the database pool of 500 connections was exhausted. The root cause is writing independent data fetches sequentially with individual await statements, causing each query to wait for the previous one to complete. This multiplies total page load time by the number of queries. The fix: wrap every shared data function with React Cache to deduplicate within a request. Use Promise.all to parallelize independent fetches. For persistent caching, use unstable cache with tags. This reduced the 47 queries to 8 unique queries per page, dropping database connections by 6x. This uncached Prisma query was called 47 times per page. Adding cache around it reduced duplicate calls to 8 unique queries. This Prisma query is not cached by Next.js. If 3 components call this function, you get 3 database queries. Always wrap database calls with cache or unstable cache. When each child fetches its own data, the parent renders children sequentially. Header fetches first, then article list, then sidebar, creating a waterfall even though the fetches are independent. Lift fetching to the parent. Force dynamic disables the full root cache and data cache. Every visitor triggers a full server render. Use it only on specific routes that genuinely need real-time data. To debug duplicate queries, enable Prisma query logging. You'll see every query executed. Count them per page load to identify duplicates. Then wrap the data function with cache and verify the count drops. Let's run through some common interview questions. How does Next.js cache fetch versus database queries? Fetch, auto-cached by data cache. Database queries require manual cache or unstable cache. What is a data waterfall and how do you fix it? Sequential independent awaits, fix with Promise.all for parallel execution. Explain the difference between React cache and unstable cache. Cache deduplicates within one request. Unstable cache persists across requests with revalidation. And a few frequently asked questions. Does fetch in server components cache automatically? Yes, Next.js Data Cache caches fetch responses by default. How do I cache database queries in Next.js? Use React Cache for Request-Scoped Dedup or Unstable Cache for persistent caching. What's the best way to avoid waterfalls? Use Promise.all for independent fetches and consolidate data fetching in parent components. Let's recap the key takeaways. Fetch, auto-cached, database queries are not. Use cache for Request-Scoped Dedup. Use unstable cache for persistent caching. Parallelize independent fetches with Promise.all. Ready to go deeper? Up next, styling in Next.js 16, Tailwind CSS modules and global styles, then image and font optimization in Next.js 16, then loading UI, streaming, and suspense boundaries in Next.js 16, and error handling in Next.js 16, error, JS, not found, JS, and global errors. Find them all at TheCodeForge.io. Thanks for watching. The full article and code examples are covered in detail at TheCodeForge.io.